Hey everybody. Last time in class we used proportional thinking to solve word problems. Right now we're going to formalize that type of thinking and we're going to use it to write ratios and proportions and solve them to solve some more complex problems. The first key concept that we need to know is what is a ratio. A ratio uses division to compare two quantities. You can write the ratio of two quantities, A and B, where B is not equal to 0 in three ways. You can write it as A to B, you can write it as A colon B, and you can write it as A over B. That's why B can't be 0, because we can't have a 0 in the denominator. Each ratio is read the ratio of A to B. It doesn't matter how it's written, it means the same thing. And ratio should always be written in simplest form. Just like we always want to simplify fractions, it doesn't matter how we write a ratio, we want to write it in simplest form. We have an example at the bottom here where we want to write a ratio for A and B here. When a volleyball team plays 14 home matches and 10 away matches, we can write the ratio of home matches to away matches. We can write it three different ways. So here we have A. We can write it as 14 to 10. We can write it as 14 colon 10, and we can write it as 14 over 10. But remember, we always want these to be simplified in simplest form. So I can divide 14 and 10, I can divide them both by 2. So actually it's going to be 7 to 5, 7 colon 5, and 7 over 5, right? So these are our final answers here. This is how we can write our ratios. Now for B, I'm going to put B over here. I want to find the ratio of home matches to all matches. So, you know what, I'm just going to simplify it once this time. So I'm just going to write this one as a fraction. Now I know that I have 14 home matches, and it says to all matches. So in my denominator, I have all the matches together, 14 plus 10. So actually that's going to be 14 over 24. And when I simplify, I divide them both by 2 because they're both even numbers. I get 7 over 12. So I can write that, and like that. Sorry, I didn't have a lot of room there. So that's how we can write ratios for a situation. Here's another example. Derek and his brother decide to combine their CD collections. Derek has 44 CDs and his brother has 52 CDs. Find the specified ratio. For number 1, the number of Derek's CDs to the number of his brother's CDs, Derek has 44 over 52. Right? His brother has 52. Now we want to simplify this. I know I can divide them both by 2. So that gives me 22 over 26, and actually I can divide these by 2 also. So that gives me 11 over 13. I probably could have just divided by 4 at the very beginning. So we've got 11 over 13. Can write 11 to 13 using a colon, and we can write 11 to 13 using the word, right? So these are all valid answers. If we want the number of Derek CDs to the number of CDs in the entire collection, we still have Derek CDs in the numerator. In the denominator, we have all of the CDs in the collection that we have to put together. So this is going to give us 44 over 96. Let's try dividing by 4 this time, because that worked last time. 44 divided by 4 is 11. 96 divided by 4, you know what, we better work that one out. 96 divided by 4. 4 goes into 9 twice. 96 divided by 4 gives us 24. So 11 over 24 is our ratio, and we can write that 3 different ways. Now we can use ratios, 2 different ratios, to write a proportion. A proportion is an equation that states that 2 ratios are equivalent. The general form of a proportion is shown here when we have one ratio, A over B, is set equal to another ratio, C over D, as long as B doesn't equal 0 and D doesn't equal 0, right? Because you can't have 0 in the denominators. So an example of a proportional relationship is shown below, where it says a recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? So we can find this answer by writing a proportional relationship. Now I'm looking for how many tomatoes are needed to make 4 pints of salsa. I'm going to make sure I underline that part. Since I'm looking for the number of tomatoes, I'm going to use T. T equals the tomatoes for 4 pints of salsa. So I know that it takes 30 tomatoes to make 12 pints of salsa, and since I know this is a proportional relationship, I can set up two ratios that are equal to each other. Now I know that we're looking for 4 pints of salsa. How many tomatoes are needed to make 4 pints? I'm going to put my 4 in the denominator because that's where I put my pints of salsa in the first ratio. I have 12 pints of salsa in my first ratio. I have 4 pints of salsa in my second ratio, and they're across from each other. And I want to know how many tomatoes it takes for those 4 pints. So that's across from the 30 tomatoes. Tomatoes on top, pints of salsa on the bottom, so that these ratios match up. And now I can solve this equation. First thing I'm going to want to do, I see that 30 over 12, I'm going to want to simplify that just to make this easier. The smaller the numbers, the better. So I'm going to divide 30 by 6, and I'm going to divide 12 by 6. So that's 5 over 2 equals T over 4. And now I have T divided by 4 on the right side, so I'm going to use inverse operation. I'm going to multiply both sides by 4. Now, on the right side, these are going to cancel out because of the inverse operations. On the left side, I have 4 over 1, write that as a fraction, times 5 over 2. That's going to give me T equals 20 over 2. And if I simplify that, 20 divided by 2 is 10. T equals 10. So our answer is 10 tomatoes. Let's take a look at another example. The elevator that takes passengers from the lobby of the John Hancock Center in Chicago to the observation level travels 150 feet in 5 seconds. The observation level is located on the 94th floor at 1,029 feet above the ground. Find the time it takes the elevator to travel from the lobby to the observation level. So let's underline what we're looking for. First step in the STAR process. Find the time it takes. So I'm going to set T equal to the time for this example, because that's what we're looking for. And that time is in seconds. So we'll just note that. We're looking for T in the number of seconds. All right. So we know that it travels 150 feet in 5 seconds. I'm going to box that information because that is important. That gives us a rate. And we know that the observation level is at 129 feet above the ground. Okay, so we can eliminate the rest of this information because we have the information we need boxed in. I don't need to know what floor it is because I know the feet. Okay, so now we can write our proportion because this is a proportional relationship. I know that it goes 150 feet in 5 seconds. And this is going to be proportional, so it's going to be equal to, and I have 1,029 feet. Now, since I have the feet on top in my first fraction, I need my feet in the numerator in my second fraction, 1,029. And T in this case is going to go in the denominator. Now, I'm going to show you a little trick you can do if you have two fractions that are equal to each other. Remember to keep this equal. Anything we do to one side, we can do to the other. We can actually take this right side and just write the reciprocal of it, as long as we take the left side and do the same thing, 5 over 150. We can take the reciprocal of the right side if we take the reciprocal of the left side. We're just going to flip both of them. Now, if this was 1,029 over t plus 5, we couldn't do it because that's more complicated. But if we just have fractions, we can just take the reciprocals. So now I have my t in the numerator. I want to simplify over here. I'm going to divide both of these by 5. And I'm going to write this over here. T over 1029 equals 5 divided by 5 is 1, and 150 divided by 5 is 30. And now I'm just going to multiply both sides by 1029, because that's the inverse operation of division, times 1029. And I'm going to cancel over here. I'm going to get t equals 1029 times 1 is 1029 over 30. Now, I want to get an actual decimal answer for this problem because I want to have an actual number of seconds, not just a fraction. So 1029 divided by 30, I'm going to use a calculator here, and I'm going to get 34.63, and that 3 keeps repeating. So I'm going to round this to the nearest tenth. We'll say t is approximately equal to 34.6 seconds. So it'll take 34.6 seconds to go from the ground level to the observation level in the Hancock Tower. All right, that's the last example for tonight. Go ahead, finish up your notes. Please don't forget to submit, and I will see you all tomorrow.